Hello everybody! First of all, sorry for not recording videos for a while. I had some professional duties and also some health problems, so I didn't record, I guess, for a month. But here we go now with all math problems presented so far on my EVIC competitions, and I shall today solve actually only first two, because the truth is that the third problem is very hard and that nobody didn't solve it, and also I didn't solve it myself so far. But I shall say few words about it also. So we start with math problem 1. So it's interesting actually problem about triangle inequality. So let me recall. So we have 19 line segments which are actually ordered and their lengths are between 1 and 1980. And we need to prove that we can pick 3 of those 9 lines and construct a triangle using them as its sides. So let me switch to the whiteboard, and now I shall try to present a solution. So let me write first what we have. We have 1 less than or equal to x1, less than or equal to x2, less than or equal to x3, and so on until x19, which is less than or equal to 1980. Okay. So what does it mean to construct a triangle? If we have a triangle, then if A, B, C are lengths of its sides, then we know that the sum of each two of them is greater than the third one. So A plus B should always be greater than C. This is actually obvious in Euclidean geometry, that the path from this point, let me call it B, as opposite to the side B, and this one A, the shortest path is actually the side C. So if we go via the third vertex of the triangle, then this path is longer, of course. So A plus B must be greater than C. Also, A plus C is always greater than B, and B plus C is always greater than A. And that is actually enough. To construct a triangle, it is enough that we have 3 numbers such that the sum of any 2 of them is greater than the third one. So we will solve this problem by contradiction. So we will assume that we cannot choose 3 of those 19 lengths and construct a triangle, and we shall prove that this is impossible, that we obtain a statement that is obviously false. So first, we obviously have that x1 is greater or equal to 1. Also x2 as greater or equal to x1 is also greater than 1. This is obvious. So if we assume that x1, x2 and x3 are not sides of the triangle, that we cannot construct a triangle. That actually means that because x3 is the largest, because we have those inequalities here. So x3 plus any one of other two is greater than the third one. So x3 plus x1 is obviously greater than x2, because x3 is actually the biggest one. Also, x3 plus x2 is also greater than x1. So the only way how this can fail to become a triangle is if x3 is too big. If x3 is greater or equal to x1 plus x2. So if we assume that we cannot make a triangle from those 19 sides, we need to have this inequality. So x3 will be greater than x1 plus x2, actually greater than 2. And we go on. So we assume also that x2, x3, and x4 are not sides of the triangle, and similarly, because x4 is the biggest one, we should have that x4 is greater or equal to x2 plus x3. So x4 will be greater than x2 plus x3, which is greater than, we use the previous inequalities, greater than 1 plus 2 is greater than 3. Actually, what we obtain that x1 is greater than the first Fibonacci number, f1, that x2 is greater or equal to the second Fibonacci number, f2, x3 is greater or equal to third Fibonacci number, x4 is greater or equal to the fifth Fibonacci number, and if we continue this way, x5 will be greater than the fifth Fibonacci number, and x6 will be greater or equal to the sixth Fibonacci number, and finally x19 will be greater than 19 Fibonacci numbers. And this will be actually a contradiction, because 19 Fibonacci number is greater than 1980. I don't recall exactly, but it's greater than 4,000. 4,000 and something is 19 Fibonacci number. Fibonacci numbers are 1, 1, 2, 3, 5, 8, 13, and so on. And on the 19th place, we will have this number greater than 4,000. And we assumed at the beginning that x19 is less than or equal to 1980. So this is a contradiction. So it's impossible that we cannot find a triangle, and the proof is complete. So this is a nice example where actually Fibonacci sequence appears. Fibonacci sequence is also familiar to you from some of my numerical IQ tests, I guess. So and now it appears here also. Just actually nice choice for the first math problem here, I guess, although it was by pure chance, actually by chosen by a random number. Okay, so this is the first one, and I shall now clear this. And let us recall now the second problem. The second problem was the problem from the theory of integers, actually the theory about greatest common divisor and largest, actually the greatest common divisor and the least common multiple. So we are looking for the solutions of the system where x is between 1 and 50, y is between 1 and 20, and the greatest common divisor of two numbers is actually one of them, and the least common multiple is the other of those two numbers. So just let me repeat this on the whiteboard first. So we have, so we have that greatest common divisor of x and y is x, and that the least common multiple of x and y is y. X is between 1 and 50, and y is between 1 and 20. Okay, first we notice that actually it is enough to give only one of those two statements. So this one is actually enough, and from this one will follow the second one. The reason is that the greatest common divisor of two numbers multiplied with latest common multiple of two numbers are always equal to x times y. So if this one is x, so the second one should be y. So we have in some way too many data here actually. Only one of these two statements were enough actually. So why is this so? So actually we can write x and y as their greatest common divisor multiplied by two numbers x0 and y0 which have no common divisors. Actually the greatest common divisor from x0 and y0 is 1. We call them relatively prime, that they are relatively prime. So if x is equal to the greatest common divisor as stated in this problem, then actually we conclude that x0 is equal to 1 here. So x0 is equal to 1. This is now obviously satisfied, and y0 can be anything. So we also conclude that y is a multiple of x, because so this is x. So this second statement can be written as y equals x times 0, 1. This will be also our conclusion. And actually, okay, I didn't prove till end this first this statement here, also, although it is not important for the solution of this problem, but let me short it briefly. So latest common multiple of x and y from these statements here is obviously the greatest common divisor times x0 and times y0. And so from this it is actually obvious that if we multiply x times y using these statements, and if we multiply the greatest common divisor and the least common multiply using this formula for the least common multiple, we will obtain both on the left side and on the right side actually greatest common divisor squared time x0 time y0. So both the left hand side is equal to this value and the right hand side is equal to this value. So this is always true, not just in the case of our problem here. So in our problem we concluded that actually y should be multiply of x, and now we have actually easy computation. So if x is equal to 1, then y can be any number from 1 to 20, because we are limited with 20 here. So we have 20 solutions here. If x is equal to, then y should be a multiply of x. So 2, 4 to 20, there will be 10 more solutions here. If x is equal to 3, y can be 3, 6 to 18, no more than 20. So 6 more solutions here. X is equal to 4, y could be 4, 8, 12, 16 and 20. So 5 more solutions. If x is equal to 5, y could be 5, 10, 15 and 20. So 4 more solutions. If x is equal to 6, then y could be 6, 12 or 18, so 3 more solutions. If x is equal to 7, y could be 7 or 14, 2 more solutions. If x is equal to 8, y could be 8 or 16, also 2 more solutions. If x is equal to 9, y could be 9 or 18, so also 2 more solutions. If x is equal to 10, y could be 10 or 20, so also 2 more solutions. And if x is any number from 11 to 20, then y should be equal to x, because other multiples are bigger than 20. So these are 10 more solutions, and when we sum 20, 30, 40, 46, 50, 55, 60, 66. So 66 solutions all in total for this problem here. Okay, as you saw, actually those two problems are not hard, but the third one is actually very hard. So let me repeat the math problem 3. It is actually a nice relation between which relates a radius of circumscribed circle and inscribed circle of the triangle, and it's a very nice theory about those two circles of the triangle. There is also famous Euler formula which somehow relates little r, big R with the distance of the centers of those two circles, and I suspect that this is somehow maybe important in proving this fact too, but I didn't so far managed to connect this with the angles of the triangle, as this is one arbitrarily chosen angle alpha of the triangle. I guess, of course, that similar is valid for any other angle of the triangle. So at this point I will not present the solution because I actually failed to see. I knew something about that theory of circumscribed and inscribed circle, and I also have some books about that, and maybe I waited until end. I tried today to solve this, and it was not enough. Actually I shall maybe not solve even with more time. It's actually it's not easy. I guess that the geometric picture for this problem will be pretty hard to follow if somebody get the solution. I have a feeling that the solution is really not easy. So maybe I shall say some more in some other video, but I will first try to solve more to put more effort to solve this, and then I shall at least partially try to say something about this problem. I shall have now time for that because the other problem for next 2 weeks published today with a little delay, but this one is actually pretty easy. It seems ugly. It seems ugly relations here with these powers, many powers and square root. But it's not. It's actually, if you get a right idea, it's a 5 minutes task. It's really elementary. I hope that this video will help, that more of you send your solutions. Only 2 people send solutions for the first 2. One of them sent also for the problem 3, but it was only partial try and with an error actually. So yes, I know. I'm certain that the problem is not easy. But this one I have some experience with some of with elementary mathematics. So this one was just solved by me in head in seconds. So I just can see what is the right idea here. So you really don't need don't need much knowledge to solve. I'm pretty much sure that with the right idea, kids in elementary school can solve this. But you need to get the right idea that you can easily get this in a simple way. So the trick is actually to simplify this expression quickly. Okay, I helped you a little bit, of course, not revealing everything. And so enjoy in those math problems. It is actually sometimes they will be hard, but sometimes they are really approachable to anybody who like to think in a logical way, just like in IQ tests. And so most of you probably know me from IQ tests, and so this is also a nice practice for your brain and to improve your logic. Okay, see you next time. Bye bye.